Okay, class, we're about to start section 1.6, which is functions. Okay, we deal first with the definition of relation, a correspondence between a first set of independent values called the domain and a second set of dependent values called the range. Now, typically when we deal with the domain, that also means the x value, and it also means the input. And here with the range, we know that means the y value, and also it means the output. Okay, now it says find the domain and range of the following relationships. Now, if you notice, these are all ordered pairs. So we know the first value is your x values, which will be your input or your domain. And the second value is your y, which is your output, which is your range. So we'll write domain, and we will use braces, and we will write down all of the x values. Typically, we try and write them in order as they appear. Well, actually in numerical order. So it'll be -2, 0, 2, and 3. From the smallest to the highest. So we have range. So we will have -1, 3, and also 4. Now, whenever we have a number that repeats, we do not write that number twice. Like here, if you notice, for your range, the -1s repeat, but we only wrote it once. So whenever you have repeaters in your domain or range, you just write it once. Okay, now we go here to B. We also want our domain, and we also want the range. Now the domain is all of your x values, so it'll be -2, 1, and also 3. Your range will be 0, 5, 10, and also 15. Now we scroll down to C here. Now if you notice here, we have these 5 points. Now we can still do the domain and range. All we have to do is write down what our x values are. Starting from the left to the right, we had -5, we will have -2, 0, we will have 1, and also 4. That will be our domain. Now our range is all of our y values. If you notice here, all of your y values are the same, which is 3. So you would just put 3, and that's it. Now we come here to D. Now we have input and output. Remember, input is the same as an x, and output is the same as y. Or we could say domain, and this is also your range. So now we need to write this out. Domain and range. This time I'll write the values below them. Okay, so if we have here, we have all of these values here. So what we could do is this here. We could write them just basically by their names. We could do the polar bear. I'll just put a P. Polar bear. The cow, I'll put CO. The chimpanzee, CH. We got the giraffe and gorilla, GI for the giraffe. Gorilla would be GO. Kangaroo, we could just put K, and red fox would be RF. Now, of course, if you want to write out all of the names, feel free to do so. Okay, now, for the output, we'll put these numbers in order. We have 7, 10, 15, and 20. Okay, now we scroll down here to E and F. Now we're still going to do a domain and also a range. Now, this is what we need to do. We need to go from left to right. Now, if you notice here, we start at -4 and we end at +4. Now, this is your domain. Even though these lines are going kind of squiggly here, we cannot write out all the numbers like we did here. See, these were exact points. But because we have this in a graph, it's not exactly a line. It's like a squiggly shape. I won't even call it a line because usually lines are more so straight. But this is a squiggly shape here. So what we would do is this here. We will put a bracket, not a brace. We'll put a bracket and we'll put our lowest number, which is -4. Then we will put our highest number, which is 4. And we will put another bracket here. Now, whenever you do set notation, which we're doing right now, whenever you use a bracket, that means that this number is included. So we know -4 is included with this domain and 4 is included with this domain. That is why we use brackets. Whenever you use a parenthesis, that means that those values are not included. Okay, now we go for the range. The lowest y value here is -2. The highest y value is +4. And you notice they are included. So you'll put your bracket, it'll be -2, +4. And that is your domain and range. That means this includes all numbers from -4 to +4 for your domain and from -2 to +4 for your range. Now we go here to F. Using the same thing. We add domain. We have range. Now, the first thing we look here is for our x value. The lowest x value is here, which is -4. And the highest x value would be 5. And they're included. So it'll be -4, 5. And this will be in a bracket. Now, if we go to the range, our lowest y value is -4. Our highest y value is +4. And they are included, which means they are part of the graph. So we add -4, +4. And that's it. Now we go to the next page. Now we go to function. A function is a special type of relation where each member of the domain corresponds to exactly one member of the range. That means that in order for it to be a function, no x values can repeat. So we look here. Determine whether the following relations are a function. If not, explain. Okay, now you have here, we have -2, 2, 0, and 3. We don't even need to look at the y values. All we have to do is look at the x values. If the x values do not repeat, then it's a function, which it is here. We look over here. We look at these x values. We have -3, 1, 1. Okay, we got a repeater with 1 and 1. So it's not a function. Based upon this definition up here, no x values can repeat. So we go here to C. We look at our x values. None of them repeat, so it's a function. Here we look at our x values here. We have repeaters with the 1s. So these 1s repeat, so then that means that it's not a function. Now we scroll down here to E. Now remember, input is basically our x value. If we have 2 arrows going from one of our x values, 2 or more arrows going from our x value or input, that means that it's not a function. We have 2 arrows going from A, so it's not a function. Now we look here. We just have to look at from our input. Are there 2 arrows going from anything in our input? No. So our answer is it's a function. Now again, remember, it doesn't matter that all these arrows, like we got 3 arrows going to 20 and 2 arrows going to 7, it doesn't matter that they end up with multiple, the same number for the output. The main thing is the input or x value cannot repeat. So now, it says here, consider a graph of the relation. We have -3, 2, 1, -2, 1, 3, 3, -1, 5, 5. How can it be determined from the graph that the relation is not a function? Okay, now we look here. Now we have to remember the definition that I gave you all. The definition said that we cannot have any x values repeat. And what you could do is this here. If you draw a line, a vertical line anywhere on the x-axis, it should not hit more than 1 point. If it hit more than 1 point, then that means it's not a function. Now, if you look here, if we drew a straight line here, it would hit both of these points. Now, I took the liberty of drawing a straight line here to show that it hits both of these points. So automatically, you should know that this is not a function. Not a function. Because the vertical line hits 2 points at the same x value. Okay. Now we scroll down here. This is a formal definition. Vertical line test. A relation is a function if and only if every vertical line intersects the graph only once. That means that it only hits the points on that x value one time. Any more than that, it is not a function. Okay, now we're going to put this to the test. It says determine whether the following relations are functions. If not, explain. So we could draw multiple, well, let me get here. We could draw multiple vertical lines. Now, of course, you all have a straight edge, but you could draw straight lines here. And if you notice, it will only hit 1 point on this graph. So we could just say that this is a function. Now, if we drew a vertical line here, you notice it hits 2 points on this 2 points on this graph. So it's automatically not a function. It did not pass the vertical line test. Now we scroll here to the next page. It says determine whether the following relations are functions. If not, explain. Now if you look here, we have all of these points. We do not have 2 points that have the same x value. So this is a function. Now B, we look here. We have this vertical line. We could draw a vertical line straight on top of this and it would hit every point on this line. So this is not a function because it would hit more than 1 point. Now we come here to C. This line here, no matter where we draw a vertical line at, it will only hit this line 1 time. So this is a function. Now we come here to D. We look at all of these points. None of these points have 2 points that have the same x value, so this is also a function. Now we scroll down here. Now one thing you need to know whenever you're dealing with an equation, if you have y equals mx plus b, that is automatically, that will be a function. You will not have any x value that will repeat in this problem here. Also, here we have y equals 42.5. We know we would not have any